This is a video on converting from rectangular to polar coordinates. The question states, write the following as a single integral in polar coordinates. And we have a sum of two integrals. The first is a double integral where x goes from 0 to root 2 over 2 and y goes from 0 to x of f of xy dy dx. And the second is a double integral with x going from root 2 over 2 to 1 and y going from 0 to the square root of 1 minus x squared of f of xy dy dx. And the trick on this one is to sketch the picture where we put the regions for both of those integrals in the same graph. So here's the picture, and let me explain it in a little more detail. We have that y goes from 0 to x, so that means the bottom curve is 0, and the top curve is y equals x. We have x going from 0 to root 2 over 2, so I stopped it at root 2 over 2, which is just around here. For the second integral, we have y going from 0 to the square root of 1 minus x squared. So the bottom curve is y equals 0, which is the x-axis. And the top curve, y equals the square root of 1 minus x squared, that's the same as x squared plus y squared is 1, which is the unit circle. So I draw this piece of the unit circle that stops at x equals root 2 over 2. So if I put these together, I see that they combine to form a wedge of the unit circle, and they do meet at root 2 over 2. So in polar coordinates, this is actually quite nice, because we can think of a radius going from the origin or from 0 to the circle, which is a radius 1. And the angle goes from the x-axis, which is theta equals 0, to the line y equals x, which is theta equals pi over 4. So I can write this integral, or the integral sum, as a single expression with a double integral in polar coordinates. So theta, as we said, goes from 0 to pi over 4, and r goes from 0 to 1, and we have our function, but instead of x, we write r cosine theta, because that's the formula for x, and instead of y, we write r sine of theta, because that's the formula for y. And instead of dy dx, we write r dr d theta. So there's my integral expressed in polar coordinates. And I'm done with the problem.